Subscribers, welcome back to my channel. Today I'm going to show you on how to use observed angle to get corrected bearing. On the board I have from station, back bearing, observed angle, forward bearing, correction to bearing, and I have my 3 coordinates, a node coordinate whereby you reference your job to. When you are doing a transverse computation, you have to have controls where you are going to start your job and you also close to either a closed transverse or open transverse. Firstly, let me explain the principle of the computation to you. The first thing is that when carrying out an observation using theodolites, the thing there is that you have to take angular observation on site and then you take your distance. Now, what you have on the board here that you can see observed angles. These are my observed angle for each stations. Now, what I did was that to obtain this observed angle, in order for you to obtain observed angle, what you will do is that on site you have to take your observation, that is for your instrument. You have to obtain your left, right, that is L1, L2, R1 and R2. Then after you obtain your left, right observation, L1, L2, R1, R2, then you deduce it to obtain your observed angle. So to deduce it, what you simply do is that you say L2 minus L1. You can see on the board here I have L2 minus L1, that is this minus this, which I was able to obtain this, and also R1 minus R2, this minus this, which I was able to obtain this. Then the mean of the value, that is addition of these two divided by 2, is going to give me this. So like this type of thing now is what we call observed angle. These are the observation on site. Then after the deduction, you'll be able to obtain your observed angle. So that's just on how to obtain observed angle. I believe now you are clear on how to obtain observed angle of sight based on what I just explained now. Now the next thing for you to do is that I told you earlier on that you are going to have some set of controls. These are the coordinates of the controls. I have 3 sets of controls, and these are the coordinates of the 3 controls. It depends on the type of control you want to use to carry out your traversing. It depends, but my observation is I'm setting on C2, which is this, which are the coordinate for the C2 control is this and this, nothing and this thing. Then I did back computation to obtain the bearing and distance for the 3 sets of controls. Now then I was able to have my corrected bearing after the computation. I told you I'm starting with I'm referencing my job to C2, so that is why I have here. This is the observed angle for C2, the field observation for field C2. Now to have my back bearing for C2, the control that I use, what I will do is that kindly note that bearing is different from angle. This one here from the table you will see observed angle. These ones are observed angle. Why this is corrected bearing is quietly different. Bearing is computed angles that I told you earlier on. The process we are doing now, we are going to arrive on corrected bearing. That is the purpose of the video. You just watch me through while I will please you through on how to obtain bearing. But these ones here that we have on the board here are angles that was obtained on site that I told you we have L1, L2 like that. Now, and then this is the controls C2. So what you simply do is that we have on the board, we have back bearing, and the back bearing for this is from C2 to C3 is forward. So to obtain my back bearing for this value, which is 30 degrees, 35 minutes, 49.9 seconds, what I will simply do is I'll add 180 to it. So when adding 180 to it, I'm going to obtain 210 degree 35 minutes 49.9 seconds. Let me quickly show you what I'm trying to say. What I'm trying to say is that in a situation whereby we have, let's assume this is our C3, this is our C2, while this is our C1. Now you want to obtain the back bearing for C1. It's going to be 180 minus the value, or the value minus 180, depending on the value you have. If the value is more than 180, so it's going to be subtracted from 180. But if the value is above 180, it's going to be 180 plus the value. What I'm saying is that in a situation where we have like 151 degree 15 minutes 10 seconds, to obtain the back bearing for this C1 now, that is, want to obtain the back bearing, is going to be 180 degree plus 151 degree 15 minutes 10 seconds. But I don't mean this is 250 because it's above 180. It's going to be minus 180. Likewise, C2 to C3. If you want to obtain the back bearing for C3 to C2, same procedure. It's going to be 180 plus the value. If the value is less than 180, but if the value is more than 180, it's going to be the value minus 180. I believe you get that. So let's continue with what I'm saying. Now I added 180 to this because the value is less than 180. That was why I was able to obtain this. And then this is the observed angle. You can see observed angle is the second observation. Why the forward bearing now is the last value that we're going to use. So to obtain your forward bearing, what you simply do is that we computed for the back bearing of the control that was used. That was how we were able to obtain the back bearing of this. While the observed angle was the observation made on site that has been deducted, that I showed you at first. So you add these two together, which is going to give me 210 degree 35 minutes 49.9 seconds plus 232 degree 41 minutes 7 seconds is going to give me 443 degrees 16 minutes 56.9 seconds. But because the value is more than 360, and you know a circle reading will give you 360 degree. So what you simply do is you subtract 360 from the value. So the result is going to be 83 degree 16 minutes 56.9 seconds. So we now have the back bearing, which is this, observed angle, which is this, while the forward bearing, which is this value. Next thing is for us to get our back bearing, which is this line here. You know, the last observation was the last reading we obtained was forward bearing. Now to get our back bearing for the next station, what we are going to do, like I said earlier on, is either going to be plus 180 or minus 180, depending on the value you have. But the value you have now is less than 180, so we add 180 to this value. So 180 plus 83 degree is equals to 263 degree. 180 plus this value will give us 263. But if this value is more than 180, it's going to be 180 minus this value. So, and then we have 1656.9 seconds. Then you add these two together, 263 degree, 16 minutes, 56.9 seconds plus 165 degree, 20 minutes, 43 seconds. It's going to give us 428 degrees. So you subtract 360 from it. If you are obtaining a result that is above 360, you subtract 360 from it. We have 428 degrees, 37 minutes, 39.9 seconds. So you subtract 360 from it because it's more than 360. And it's going to give us 68 degrees, 37 minutes, 39.9 seconds. Now to obtain our back bearing for next station, we are going to add 180 to it because the value here is not up to 180. You know the forward bearing, this is the forward bearing with so 180 plus this value now, 180 degree plus 68 degree, 37 minutes, 39.9 seconds is going to give us 248 degree, 37 minutes, 39.9 seconds. Then you add your back bearing plus observed angle together, which is 2 plus 280 degree, 00 minutes, 47 seconds. It's going to give us 528 degree. Then you subtract 360 from your result. So we have 168 degree, 38 minutes, 26.9 seconds. You add 180 to it because it's not 180 to get your back bearing. 168 degree, 38 minutes, 26.9 seconds plus 180 degree is going to give us 348 degree, 38 minutes, 26.9 seconds. Now you add these two together. After adding your observed angle plus your back bearing plus observed angle together, we're able to obtain 630 degrees. So you subtract 360 from the value. So we have 270 degree, 8 minutes, 08 minutes, 57.9 seconds. Then now you see for our forward bearing now we have 270 degree, the forward bearing we have 270 degree, 08 minutes, 57.9 seconds. But this value now is more than 180. So you subtract 180 from it to get your back bearing for your next station. So 180 minus the value now, we have 90 degree, 8 minutes, 57.9 seconds. So you add these two together plus 188 degree, 43 minutes, 49 seconds is going to give us 278 degree, 52 minutes, 46.9 seconds minus 180. We have 98 degree, 52 minutes, 46.9 seconds. No, now you have these two together now. Plus 291 degree, 42 minutes, 51 seconds. Now we have 390 degrees. So you subtract 390, you subtract 360 from the value. So we have, after subtracting 360 from the value, we have 30 degree, 35 minutes, 37.9 seconds. Now we are going to bring out this value here. We are going to write it here. Because that is the corrected bearing that we use to start our computation, to start our deduction. So now we have 30 degree, 35 minutes, 49.9 seconds. So what you simply do is that you say this subtract from this is going to give you your correction to bearing. That is 30 degree, 35 minutes, 49.9 seconds minus 30 degree, 35 minutes, 37.9 seconds. So we are able to get 0 degree, 0 minutes, 12 seconds for our correction to bearing. So what we simply do is to distribute this correction to all our forward bearing in order for us to be able to obtain the corrected bearing. Now to do that, the first thing you have to note is the number of station. Number of station. That is the first thing you have to note. So the number of station is 1, 2, 3, 4, 5, 6. We have 6 number of stations. Number of station is equal to 6. So after obtaining your number of stations, the next thing is to bring out your correction to bearing. Our correction to bearing is 0 degree, 0 minutes, 12 seconds. Now you now say your correction to bearing divided by the total number of your station, which is 6, is going to give us what? It's going to give us 0 degree, 0 minutes, 2 seconds. After we divided the total number of correction to the bearing divided by the number of stations, we are able to obtain 0 degree, 0 minutes, 2 seconds. So you distribute it to each number of stations. In order for you to do that, what you do is that you say this is the first station on our forward bearing. You want to get the correction for this place here. So to get that, you say 0 degree, 0 minutes, 12 seconds divided by 6, which is equals to what? 0 degree, 0 minutes, 2 seconds. What I wrote on the board. Multiply by station 1, because this is the station, your first station. So we're able to get what? 0 degree plus. You have to note it. It's either going to be plus or minus. The reason why it's plus is that this value that we put down here, subtract from this, we're able to get plus. So that is why it's plus. 0 degree, 0 minutes, 2 seconds. And you can also write it like this. If you don't write it like this, you can just write it like this. You just write plus 2 seconds. And then to do the next, to calculate for the next station, which is this, is going to be 0 degree, 0 minutes, 12 seconds divided by 6, multiplied by station 2, is going to give us 4. So this is going to be plus 4. You continue repeating the process for the next station now, which is this. This one is going to be plus 6 seconds. The next one is going to be plus, when you punch your calculator, it's going to be plus 8 seconds. Likewise, this station here is supposed to give you plus 10 seconds. So what you do now is addition of this plus this 2 seconds. This is 2 seconds. It's going to give us 83 degree. To get the corrected bearing now, it's going to give us this plus this 83 degree, 16 minutes. So this one is going to be 58.9 seconds. And then for the next one, this one is going to be addition of this plus this. It's going to give us 68 degree, 27 minutes, 43.9 seconds. This one is going to give us 168 degree, 38 minutes. This 26 plus 6, that is 32.9 seconds. Likewise, this is going to give us remain to 1 minute. So this one is going to be 9. While this one is going to be 5.9. So for this now, it's going to give us 278 degree, 52 minutes, 56.9 seconds. Now, this is how to compute for corrected bearing. With this now and your distance obtained on site, you can get your data notice and data listing. Then you'll be able to get your final coordinate and plot your traverse. You can just watch my video on how to compute fault computation. Thank you.